Welcome. We are in Khan Academy on Algebra 1, and we're now in the unit Quadratic Functions and Equations. And so the first skill in this unit is called Parabolas Intro. A parabola is an object. It's an object that looks like this. Here's a graph of a parabola. It's this blue curve. There are several, or there are a few examples. So here's a parabola, here's a parabola. They're graphed on the Cartesian coordinate plane, x-axis, y-axis. And these are graphs of quadratic functions. So a quadratic function can be expressed in several different ways, just like linear functions can be done in standard form, point-slope form, slope-intercept form, and other representations or other forms of equations will give you lines. Similarly, quadratic functions can be expressed in several ways, but they will graph with a common shape. It will look like that. It will have either a maximum point or a minimum point, and it will go down or it will go up from the maximum or the minimum respectively. So for example, here's a quadratic function. We would have written in function notation f of x equals 3x squared minus 2x plus 1. Just off the top of my head, some function where f of x is the y value, so I could rewrite that as y equals 3x squared minus 2x plus 1. You've seen in the past some linear functions. Here's a linear function, y equals negative 2x plus 1. This part is a linear part of the function. What makes the function curve is that the input x is getting squared. So as x increases, you're going to have the y value either decrease or increase by a square of the x, meaning it's going to increase faster than x is, or it's going to decrease faster than x. So in this case, as x gets really large, we're squaring a really large number, which makes it even bigger, and then we're multiplying it by positive 3. So as x increases toward infinity, the y value is also going to skyrocket faster and faster toward infinity. So you see that if you have a positive coefficient on your highest term, your x squared term, that you're going to have a parabola that opens up like this. If this were negative 3, if the coefficient on the x squared term were negative, then as x gets really large, it's getting squared, and then the y value is getting really, really, really big. The value of y is getting big. But if we multiply it by a negative, like this, then negative 3 times something really large is going to be a very negative number. That is, it's going to be decreasing. The y value will be decreasing as the x value increases. That gives you a parabola like this first one. As x gets really large, y decreases. Okay, so we'll see that again in the future. But for right now, all they ask us about is, does it open up or open down? Think of it like a bowl, right? A parabola is curving. So if you have a bowl and you set it on a table, you want it to open up so you can have your cereal in there so it doesn't spill out, right? So it opens up if it's shaped like this function. This doesn't open up. That's the bowl being upside down. It's not going to hold anything. It opens down. This one opens up, just like a bowl that's sitting so you can use it. All right? Now we picked two answers. Is that okay? They say choose all the answers that apply. So it could have just been one. It could have been all three. Or it could have been two. And in this case, it was two of them. Next problem. Draw a parabola's axis of symmetry. Okay, so we need to know what an axis of symmetry is. I have an axis of symmetry. I mean, not a perfect one because I'm a person. My left hand's bigger than my right hand, for example. My ears aren't on straight. Probably yours aren't either. Almost no one's are. So, but we know, right, I have a left and a right side to my body. My axis of symmetry would be theoretically where we could fold me in half and I would line up, right? The one half is the same as the other half. So the axis of symmetry in a parabola is going to go vertically when the parabola opens down or up. So we're going to swing this around. And then you have to be able to fold that parabola, or imagine folding it right over that line of symmetry, and it should line up with itself. That means we better put one of these points right on the vertex of the parabola, that maximum point or minimum point. That's the point where your symmetry happens, right? It's going to go down from it on one side and on the other. And it needs to be vertical because we're folding it over like so, okay? Next, mark the vertex. So I just mentioned what a vertex is. The vertex is the point on a parabola that is either its minimum because it opens up, or it's the maximum because it opens down. So in this one, we want to put our vertex on the minimum. Which parabola has exactly one x-intercept? An x-intercept is where a function crosses the x-axis. Let's look. This one crosses the axis at 1, 2 points. This one doesn't touch the x-axis at all. That's interesting. Linear equations, unless they're horizontal, are going to cross the x-axis at some point, but parabolas don't necessarily. All right, that one doesn't touch it at all, has no x-intercepts. This one has a vertex right on the x-axis. This one is the only one that has a single x-intercept. Graph a parabola whose vertex is at 3, 5 with a y-intercept at y equals 1. Okay, so they give us some location. Remember, locations of points, of course, x comma y. So my x-coordinate is 3, and my y-coordinate is positive 5. And then they want my y-intercept at y equals 1. That y-intercept is where your function crosses the y-axis. So here's the y-axis. I need a point at y equals 1. That's over here. Well, I better swing this over there. I don't want to put my vertex on it, because even though that would put a point there, it would then not have the vertex where it belongs. Fair enough. Graph a parabola whose x-intercepts are at x equals negative 3 and x equals 5, and whose minimum value is y equals negative 4. So the value of a function is whatever the y is when you put in an x coordinate. Okay, so y has to equal, on our vertex, the y coordinate has to equal negative 4. Let's write that over here. So the vertex is at some x value we don't know, and negative 4 for the y value. So first thing we want to do is get that off of the x-axis, because they tell us x-intercepts. I'm going to cross the x-axis at negative 3 and 5. So let's put this on negative 3. So I know I have that in the right place. And then look at what happens. If I shift this, remember the parabola is symmetrical, so if I shift this point to the left, what's going to happen, and that point's fixed, if I shift this one to the left, what's going to happen to the x-intercept over here? It's going to move right or left. If I move the vertex left, this is symmetric. If I move that over, this moves over to the left also. Notice, there's two spaces, 1, 2, from my first x-intercept to my vertex. And there's 1, 2 spaces from my vertex to the other x-intercept, because it's symmetrical. Okay, so how am I going to get this point to hit positive 5? I'm going to have to move it that way. That got closer. There it is. Now there's 1, 2, 3, 4 steps from the first x-intercept to the vertex. And then there's 1, 2, 3, 4 steps from the vertex to the second x-intercept. Fair enough. My minimum value, the minimum y value of this function is -4. I don't have it there yet. Let's see what we can do about that. It's on -3 right now. I need it at -4. Notice, if I move this up or down, it doesn't change my x-intercepts because the function is symmetric. So no matter where I put this up and down, it's still going to cross the x-axis at the same places. So there we go. We've got a vertex that is the minimum value of this function at y equals -4. We've got an x-intercept at -3 and at +5. And that one's done. Last question. A parabola intersects the x-axis at x equals 3 and x equals 9. What is the x-coordinate of the parabola's vertex? Okay, so let's graph that. What we know of it. They didn't give us enough to know everything about the function, but they did tell us that we cross the x-axis at 1, 2, 3, and 4, 5, 6, 7, 8, 9. Okay, we cross here and here. Now, it's symmetric like we talked about, so the vertex has to be halfway between those points. So maybe it opens down like so, and it has an axis of symmetry straight through the vertex. I didn't draw it very well, but you get the idea. It has to be, that axis of symmetry has to be halfway from 3 to 9. Halfway from 3 to 9 is 6, which is where it landed here. So the x-coordinate here has to be 6. They didn't tell us enough information to know where y is. It could have been up here, it could have been down there with the parabola opening up. But we have enough to answer what they asked for. The x-coordinate of the vertex is 6. And we are done.